dropped a package on our Slack channel at the bottom here. It's the nav mesh tutorial. I found it on the Unity Learn portal. It's an older tutorial, but it's a good one. Everything still works. It was from Unity 2017, I think, even, but they haven't really changed their AI system that much in recent years, just because it's really good already, and it's highly optimized and relatively straightforward to use. And so, yeah, if you haven't gotten that already, go ahead and download the zip, just because, yeah, it has a level already for us to kind of use here. You could create all of these surfaces on your own, with Unity primitives, just by doing, 3D objects. These are all basically cubes. The reason they look like they do here is because someone actually created the models. The walls are actually a single model that was created in a third-party tool, probably Blender or 3D Studio Max. Yeah, if we wanted to, we could maybe go and look at the actual model. If you open it up in the, it's an FBX file. FBXs are usually 3D Max, I think. Blender files are blend by default, or Autodesk, I guess. I kind of lumped them together because Autodesk ended up buying 3D Studio Max and Maya, and yeah, I don't know how the SEC let it go through, but one company basically owns all of the top 3 or 4 most popular 3D modeling tools. And they charge a lot for some of these. I think Maya, I don't even remember what the license for Maya is. It's in the thousands of dollars. Yeah, it was like $1,500. They give you a discount if you're a student. It says a different version of Unity is required. What version are you using? Yeah, $4,000 for 3-year license. That's insane.
Yeah, 2019.15.
It should open. I didn't have any issues opening it in 2019. Maybe you want to just go ahead and try opening it. If it doesn't open, or if it opens with errors, maybe you can share your screen and we can go through the error messages together. But this zip file should open up in 19. I opened it up in 2019 and it didn't cause any problems, so that's kind of weird. What I did was I unzipped it, and then I just copied over all of the files. I didn't try and import it. It's not a Unity package or anything. It's a zip file, and so yeah, you should just be able to extract all of the files that are in the zip file. And yeah, there wasn't anything in here that was strange. It's basically just a bunch of materials. It's got a couple of scenes. It's got a couple of script files and a couple of models and textures, and that's, yeah, there wasn't anything in here that was should give problems for Unity. So Adam, were you able to open it when I selected 2000? It says project will be upgraded to latest version. Yeah, you should just be able to upgrade it to the latest version without any problem. They haven't messed with the nav mesh system in a while. Particle system, yeah, that was the old particle system got deprecated a couple of years ago, and so if you find old tutorials on the particle systems, they won't work. But this one, yeah, this one seemed to run fine. I went through all of this stuff already a couple hours ago just because I wanted to make sure, yeah, that we can go through it in a smooth way. So does everyone want to make sure everyone's got the package, or not the package, but all of the files imported? So if you start out with a blank scene, that's probably the best starting point. That would give us the most amount of practice. They even have a prefab for the level. And so when we start out in our new scene, we can just take this level prefab and drop it right down here. Looks like some of the materials maybe weren't set on the original prefab, but all of the pieces and everything are there, which is kind of the most important part. Yeah, I forgot to tell you guys about that hotkey. So if you push Alt, you orbit with the left mouse button, but if you use the right mouse button, it's look, or Alt and right mouse button is another way of zooming. If you don't, for some reason, have a scroll wheel, pretty much every computer mouse has a scroll wheel now. I don't even remember the last time I saw a computer mouse without a scroll wheel. So yeah, does everyone have the project imported and new scene? And then you go ahead and drop that level prefab onto the scene. If we go through here, it looks like it's just mesh rendering. It doesn't even have colliders on it or rigid bodies. And so, yeah, we can take our player. I don't know if they have a, it looks like they do have a player prefab here. Let's go ahead and drop the player prefab onto the scene as well. It's kind of misleading, right? Until you orbit around and see, in fact, it's not anywhere close to the scene. You can kind of tell maybe a little bit by the shadow that's there. And you don't want to be underneath it. So looks like our player does have a capsule collider in addition to the mesh render. Notice that the mesh render is actually a cylinder, and the collider is a capsule. So it's round on the bottom. You don't really want to use cylinder colliders for stuff that's going to move, because the friction caused on the bottom of the cylinder, the flat cylinder, it doesn't work very well with a flat surface. And so, yeah, you can kind of see if you've got the capsule collider expanded in your inspector, you can kind of see, because the material is green, it's a little hard. We could even, if we really wanted to see it, turn off that mesh render, and that's what our collider looks like on our player, and this is what the actual player looks like. Sometimes, yeah, if you're having a hard time figuring out why something isn't colliding with your object, there's a good chance that the collider and the mesh render are out of sync, because they don't have to be the same. So just, yeah, make sure you're your collider should more or less approximate what your model renders and looks like. Otherwise, yeah, you get weird things where, if you're swinging your hand or something, the hand looks like it's going through a wall or through a orc or whatever it is. And so you want to try and use a pretty good approximation, but I would advise against using a mesh collider just because they're computationally very expensive to run. Yeah, they just consume a huge amount of system resources. Some of the AAA games out there, especially the first-person shooters, I think they might use mesh colliders, but at the same time, you have to have a very souped-up computer with a fast, dedicated graphics card in order to run those things at 30 or 60 frames a second. So only the materials show up. Never mind. Okay, you got it, Adam? So yeah, we've got our player now. We've got our level. If we hit play, looks like our camera's a little out of place. We didn't set our camera. If we want to see where our camera's at, we just double click on it in the hierarchy, and it looks like, yep, that's what it was looking at. Instead, let's get it closer to our player. Rather than trying to use the handles, let's use the technique that we used last class period, where we come over to our player, we copy the transform component, which has the position, rotation, and scale, and then we can come over to our main camera, and we can go ahead and paste in those values, and now our camera has the same values as the player. And now we know we're here. We want to back up a little bit and make sure that yeah, we're not inside of the player. They can't have the exact same values, but yeah, if you expand camera here, we'll get our little preview window, so that's probably the easiest bet. You also get a frustum. This is this four-sided triangle here. This is what the camera sees. Anything outside of this, they're not going to see. We had talked about this before the clipping plane, if you want to make the clipping plane go further, because anything outside of this will be too far away and the camera won't render it. So this is a fine clipping plane, but what we want to do is we want to rotate it so it's actually looking the right direction. So we're going to rotate around this. And then let's kind of bring it up a little bit as well so that we can see the rest of the level. And then maybe rotate it down a little bit so you can actually see like that. It doesn't look exactly like it did in the other level, but at least you can see everything. And now we want to go ahead and we want to add a nav mesh surface to our level. The nav meshes are kind of the magic components that Unity has. If you do nav mesh surface, this is what you want here. And this, yeah, this is the component that you put on to your level. And if you hit bake, it automatically, you can kind of see in your scene how it determines what surfaces you can walk on. Back over here on the inspector, this kind of gives you an idea of the angles at which the AI agent will be able to climb. You can adjust all of these properties. You can even create different types of agents so that, yeah, one's a humanoid, but if you want something to be like a dog, that is able to jump higher or go up a steeper, maybe a dog's not a good example, a goat, goats can climb mountains that are really, really steep. And so, yeah, that's how you determine your different agents. Yeah, the only other thing we need is our actual agent. So over here, they already have the nav mesh agent on the prefab that we're editing. Yeah, if this weren't here, you could add it just like you add any other component where, yeah, it's a predefined Unity component. I'm sure it inherits from behavior. I think, not sure if we're able to actually open up the code. We might have to come over to the Unity API if we wanted to see the actual functions. If we do nav mesh, mesh modifier. Yeah, the first one here, or not modifier. I apologize. There's a modifier component as well, but nav mesh agent is what you put on the player, and this shows you all of the properties. There's really, it's a lot like the particle system where there's just a huge number of public methods and properties and ways of configuring your AI, because sometimes you don't want the AI to be super, super smart, right? You want it to be a little bit dumb, otherwise it ends up crushing you, right? If you've got an AI that's too good, that can really make a game not very much fun. So sometimes it's a matter of scaling back the pathfinding algorithm that the computer uses, and all of those properties can be adjusted in the nav mesh agent component. It's got the standard instantiate, destroy, transform functionality that every other component has. Yeah, if you were to look, everything's got a tag and a name, and this is just, all of this functionality is inherited from the game object component. But the ones that are unique to nav mesh are right up here at the top. Yeah, so now all we really need to do, we can hit play and it won't actually do anything. Project did not upgrade to latest version for us either. Ooh, we want to make sure that everybody can get this project into yeah, I wish you guys could follow along. You shouldn't need 2017. I didn't even get an error message. It's one of the reasons why I was so happy I found this package, is that I didn't get any kind of warnings or anything. I just dropped the assets into the asset folder and it opened up fine in 2019. Yeah, well, we'll continue, I guess. So yeah, our game runs now without any errors, anything. And what we want to do is create a script called player controller. I'll create a player controller too, since I already created a player controller earlier. You can either add it this way, there's a new script over here in the inspector, or you can right click and add new script in the project. Either way, when you double click on it, it will open it up in the Visual Studio environment. And so here's my old player controller. Basically, we just need a reference to the nav mesh agent. And then this code down here is going to be responsible for handling, what's going to happen is whenever we click on something, our agent is going to move to that our player is going to move to that position. And the way we do that is we use our input function, which everybody's familiar with now. We've mostly been using input get key, but if you want to get the mouse clicks, you've got get mouse button down. 0 is for the left mouse button, 1 is for the right mouse button, and I think 2 is for the middle mouse button. There's also a difference between get mouse button and get mouse button down. Is one involves holding it, and so this one returns true only the frame that it's down, as opposed to get mouse button, which which fires constantly, right? It's continually firing as long as you've got the mouse button held down. And then they also have another one where you can fire this event whenever you release the mouse button, which is sometimes useful if you're trying to program something that drags and drops, or yeah, some kind of analog thing where you hold a button down for so long, and then when you release that mouse button, yeah, all of the analog energy that you stored up until that point culminates and fires in the way that you want it to fire in your game. So coming down here, Ray. So this basically takes your camera. So camera.main is just a reference to your main camera. So this is one of the public classes. If you use lowercase c for camera, this doesn't actually exist. There is a camera component, but yeah, you can't do lowercase camera like you can game object or transform. But camera is a component, and it has a static variable on here called main, which gets your main camera. It's yeah, read only. You can't set main camera. It's just finds the main camera. If you want to switch which camera in your scene is the main camera, you can come over to here in the inspector, and the main camera tag is set right here. Because yeah, sometimes you'll have scenes where there's multiple cameras. If you want to change which one is the main one, then that's how you do that. Where is the script in the project? So I don't think, yeah, you won't have the script, Adam. We have to create it. Yeah, I would create a new player controller script. I created player controller 2 just because I created the player controller earlier today, and it's just kind of there for reference so I don't forget anything. Yeah, we're going through the script now, just the different things that happen. So this is basically taking our camera, and it's creating a screen to point array. This is the best way of getting the mouse position and the location of where you actually clicked. So this is a very useful function right here. This is the function that is where the user clicked. This function is so useful, I'm even going to put it into our Slack channel. So that is going to produce a array, and it's the array that it's basically a line that goes from your camera to where you actually clicked on in the scene. this is the hit position. So now that we know where in the scene they clicked on, oops, we're going to want to get that position. And so we use this physics raycast, so it's going from where we actually clicked on to where the thing's actually hitting. And then at that point, we're going to get our point. And so the way that the AI agent is set up, it's pretty easy. All you have to do is give it a vector 3. Vector 3. And it will go to that position automatically. It knows how to do it on its own. It doesn't give us too much information here. If we wanted to learn a little bit more about set destination, we could come back over to our API here, and we could search for set destination. Right here in our NavMesh agent. This is example of how to, wow, it's even almost identical to what we've written. I didn't realize, this is all written here. Guess I could have saved myself some time earlier. But it's taking a vector 3 and setting the destination. So the only other thing that you need in your player controller is a reference to the agent. This variable here is getting used. If you have the component on the same game object, which you should actually, that's probably we're going to want to put our controller on the same one as the NavMesh agent. So instead of having this public property that you have to set in the inspector, we could in fact even get rid of this and instead just do get component NavMesh agent. And this is essentially the same exact thing. And so now if we hit play, we'll come back over here. Let's go ahead and get rid of that one and add the right one here. And hit play. We should, I always save before I hit play just in case things go sideways. And so let's save our scene. We'll call it example. And hit play. And it's not working yet. We might have forgotten a step. I think we forgot to bake our level here. And now let's hit play and try and we might have forgotten a step. 1 second, I'm gonna cheat and go over to my other scene here. Works in that one. I must have forgotten a step. We've got our NavMesh surface. We've got we didn't add the NavMesh modifiers. I think if it was going, it might actually end up trying to walk through walls. And I realized that the ground here has a box collider. I think our ground in our example scene was actually missing a box collider. So let's go ahead and try adding a box collider here. Expand it, it'll put a green box around. Actually, it looks like it got it right. Sometimes Unity is smart like that. If you've got a mesh render that's a particular shape and you add a collider, it's smart enough to match up the collider with the shape. Let's go back to our nav mesh surface and rebake and make sure that it is on there. And now, there it goes. Ah, that's what we were missing. Because our surface didn't have a collider, when we tried to click on it, our ray would actually not hit anything. Our ray would kind of go off indefinitely. It's as though, you know, there's nothing there. Yeah, if you want a ray to hit something, that something has to have a collider or it won't. And I think because we don't have modifiers, our agent, I don't know, it's still smart enough to not try and go through walls. Yeah, he's cooking pretty good. Yeah, this wasn't too difficult. I hope we went through it kind of fast. I guess, do people have questions at this point? Yeah, in order to get this stuff working, all you really need to do is add a couple of components, and then everything else is just tweaking the properties in the inspector. The code is sending me a bunch of errors regarding to syntax. Do you want to share your screen real quick, Adam? That way we can take a look. I'm sure it's probably just a matter of a missing parentheses or who knows. Programming is very unforgiving. If you got a comma in the wrong spot or you're missing a semicolon, or I've even been in situations where something was supposed to be uppercase and it was lowercase or vice versa, and you can spend an hour trying to find that bug. Let's see here. I forgot to tell you guys, I think you want to use the Unity UI, the AI, I think as well. If you take that out, does it know? Should only get confused about the nav mesh agent. Yeah, go ahead and do a using Unity dot or Unity engine dot. Oh, come on, teletext. I think it's AI, just capital AI. Yeah, and this, now it knows to use the mesh rendering capabilities. I did forget to tell you guys about that. They're using a 1 or an, I use L for local. I'm pretty sure in C# you're not allowed to start a variable name with a number. Yeah. Yeah, it's sorry, I put in L's. Some people, it's a coding style thing. Some people put in P's for parameters, L's for local variables, or they put a little underscore if it's specific to a class. I use L. You know, some people use lowercase.
For some reason now
But now it should be compiling. I think everything's there except for the agent. Or no, now that we've got the Unity engine.ai, it should even recognize. Or no, we replaced agent with the nav mesh component. So you either need to define agent as a public property, and then we can set it in the inspector. Otherwise, you're going to want to replace agent with get component nav mesh agent.
Yeah, because for some reason it's saying that a camera does not contain a definition for main, and agent does not exist in the current context.
Lowercase m. Yeah, I don't know why your teletext isn't popping up either. It should have.
I mean, yeah, for this entire class, it just hasn't really been working.
You might want to try closing down Visual Studio and reopening it. Yeah, if teletext isn't working, it's makes it 10 times harder to code because you don't know what properties and functions you have at your fingertips, and you're more than likely able to fat finger something or make one of those upper lowercase issues that we literally just ran into, where main is supposed to be lowercase.
Though it's
accessing the main camera.
Now it's still saying agent doesn't exist in the current context. So do I just initialize like a public variable?
Yeah. So it's complaining about agent, or it's complaining about
agent?
Yeah, so you want to do get component, and then we're trying to get the nav mesh agent component. And then just make sure that your player in your scene has both of those components on it. So you're going to want, your player controller script that you just created, and you're going to want to have the nav mesh agent both on the same game object.
Yeah, nav mesh agent is on the player as well. And, right.
Yep. And then the only other component that we had to add was the nav mesh surface, and that wanted to be added to our level game object.
So,
Taylor, were you able to get everything working?
Although for some reason it still says, okay, the object is required for the non-static field method or property, nav mesh agent set destination.
I'm just watching along right now. My other machine I set up for travel plans. Having some issues with the internet, which we're upgrading tomorrow. But I'm working on just downloading the assets. But I'm watching the what you guys are doing.
Okay. Adam, do you want to share your screen again, just so we can, see what the issue is? Go ahead, and if you double click on the error message, it should pop up in Visual Studio and go right to. You want to do, I think your screen's a little small, but I'm pretty sure you want to do get component. And then that's where you put in the nav mesh agent, because nav mesh agent itself is not a static class, and I think that's what your council was actually trying to complain about. And then in order to get the syntax to work, you put the brackets here. Let me share my screen real quick.
Okay, so it is.
Something like this, where you do get component, and then you put in the component type, and then you put these little brackets at the end, like this. This is the syntax for getting a component on the game object that you're
So
on.
it compiled correctly, but when I hit the mouse button, it said it flagged an error saying like it needs to be apparently vector 3.
Okay, are you passing in a point? So you're not just passing the raycast.
Yeah, it's a
hit.
L raycast to hit dot point.
Okay, it should be getting it. What line, or is it having an issue with your screen point to ray?
It says a set destination can only be called. It can only be called on an active point that has been placed on the nav mesh.
It's possible you didn't bake the nav mesh yet. So you want to go to your level and go to the nav mesh surface, and then go ahead and hit that bake button. And that kind of creates a bunch of metadata and geometries and everything. And then after that, you should be all set. Make sure that your ground has a box collider on it. Otherwise, your mouse click won't register. But yeah, once you've got that going, should work.
Okay, there we go.
And I haven't even looked at all of these components. There's so many of them. If you want to turn up the properties, the speed, I think if you turn it up too high, he gets kind of fidgety and almost moves too fast. Very smart enough, gets kind of carried away and just runs into walls trying to get to the actual position. Or is moving so fast that he can't actually even get to the point. So he can't get to point 1 stopping distance because he's going so fast as he goes over the position. And maybe it'll work, but that's what happens if you haven't tweaked your game and optimized the properties. We had the same problem on Tuesday where the fog was there, but we had a hard time seeing it because we didn't have the properties set correctly. And I actually went back after class and played around with it. The reason it wasn't showing up very well is because we were using the exponential squared main property, configuration. And it was, overpowering how strong the fog was. We really just wanted a linear fog, which makes it not so intense. So, do we have any other questions? Chris, are you guys, were you able to get the nav mesh stuff working?
No, but it's okay. We don't have a scene in our project, and it could be because we had to bring it in 2019.3.14, and it said it in the up front that some components might be missing. So the scene is missing, but I don't know why that is.
Okay,
so we have all these listed assets, but not the scenes. Did you create the scene in a different way, or did it come in the project? Usually they come.
It should have came in the project. I think. let me download this zip again.
Okay.
It came from a Git repo originally. And I think, yeah, if you go through the README, it even gives you the URL where the original Git repo is. But yeah, in assets, all of these .unity files, these are the scenes right here. So I'm not sure, yeah, why you guys don't have the scenes. But yeah, maybe try re-importing, because all I really did was I took this assets folder, I did a copy, and then I came over to my project inside of assets file, and I did a paste inside of assets, and that's all I did. These assets are essentially the exact same assets that are in the zip file, except for I added the player controller, which even this player controller information is more or less right out of the API, right out of the documentation. I didn't do anything too fancy. If we wanted to, yeah, play around with the components and things, we could do that. But yeah, this is more or less just to kind of show you how easy it is to set up an AI agent in Unity, or at least one that can traverse, a flat level with just some walls.
Yeah.
Yeah, if you wanted to have somebody chase you, that would be done instead of having set destination be, your point. You have the this point be the transforms position of the thing that you're trying to chase. Does that make sense? Or maybe we should just do it. Yeah. We'll put this into start. We'll leave the functionality for the clicking there, but let's go ahead and right when we push play, we want our player to chase after and go to a certain goal. So yeah, if you guys just want to follow along, I'll show you how to do that right now. So what we want is we want a public game object, and it's going to be our goal. And then in the very beginning, all we really want to do is set our destination for the goal. And the goal is a game object. We actually want the position of the game object, so we do dot transform dot position, which is a vector 3. And now when we come back over to our game here, all we have to do is create a new sphere here. Make sure that it's not underneath our nav mesh, or it might get kind of confused. And now in our player controller, all we need to do is set our goal here. Let's rename our sphere to goal. We don't have to, but it's useful. And then drop our goal in goal. And now when we hit play, our guy should go, let me, found it. Yep, and he got to his goal. Does everyone understand how that happened? I want to make sure.
Can you just summarize it again? I like the.
Yeah, sure.
I would like to hear that again.
Yeah, so we added this new game object to our player controller, And if we wanted, instead of a game object just to get the point, we could even turn this into, we could change this to transform if we wanted to. But what's happening is in the start, whenever we hit play, start gets ran after a wake, we are getting the nav mesh agent that's on the same game object that we have our player controller, and we're doing set destination to whatever we have configured here in the inspector. And you can't just say goal, because set destination is expecting a position, and goal as it stands is not a vector 3. It's not a position. We want to get the position, which is a vector 3. And so now when we come back over here and we drop our transform in here, it says type mismatch. Unity should have been smart enough. Goal is also a transform, but yeah, we'll go ahead and redrop it in here so now it knows I'm referring not to the game object goal, but the transform. All game objects have a transform, and all transforms have a game object, but now it's just, yeah, it reconfigured itself, and it'll even show you, this is the icon for transform, and it tells you, yeah, this is a transform. And so, yeah, when we hit play, our script decides that, hey, we want to go find that that transform, and it's able to do that like so.
Okay, great. So, quick question. So, does the code also tell it to go around the objects, or is it just sensing, in effect, where the goal object is?
Yeah, it's able to detect the walls because of the nav mesh surface. And the nav mesh surface, all you have to do is drop it on your scene, and then you hit bake, and it it creates kind of this outline here, and this outline lets you know, hey, this is where you're able to go in the scene.
Where you can't go. I got it.
Yep, and where you can't go. If we wanted to have it so that he can go over walls, we could actually change this, the height or the configuration of our humanoid, so that we can go over a larger height. If we took this up to here, I'm pretty sure if we hit play now, we might have to rebake actually. 1 second, let's rebake. We just made our player able to jump like Superman, and so it is probably smart enough now. If we step height should be less than the agent height clamping internally. It's giving us a warning because we really gave it a huge step height, but let's go ahead and see if this guy just plows over the walls. Yep, he doesn't care about the walls. He's able to go over them like they're not there, because we came into his profile or her profile and switched it around so that we can jump over those walls, because I think the walls only have a height of 2, and we have a step now of 3 and almost 3.5. So if we don't want our character to go over walls, we'll set it back to 0.5. And now if I hit play, I'm pretty sure he'll jump over walls again. Yeah, we didn't rebake. That baking button is important because it reconfigures the way the artificial intelligence agent works. The baking part, that's really it creating its mind, and you have to do that before. If we wanted to make our goal and our player kind of be like lovers, we could go in and even drop this player controller onto our goal here, and as a goal, we want to get to the player. And so now the objects should actually try and come together. Oh, the goal isn't moving because the goal is actually missing the nav mesh agent. So we need to go back in here and we want to add a nav mesh agent component to our goal, and then I think we'll have the desired functionality. So there's our nav mesh agent here. Has basically the same profile as our player. And so now when we hit play, I think our objects will try and come together. Ooh, the goal didn't do a very good job of getting to our other player. Let's go ahead and do another bake and make sure everything's right. There might have been some properties over here on the nav mesh agent that were changed, because if we recall, the nav mesh agent was already on our player component. Oh, now they got it. Oh, there they go. They're happy to have. Oh, they went to.
They switched positions.
They switched positions, and do you want to know why? It's because we only ran that command once, right? We put it in start, and so right in the beginning, they set their destination, and then that destination doesn't get reset again ever. If we wanted them to find each other, we would have to put it into update. So let's just verify that my hypothesis is correct here. Let's, yeah, we can even leave that in the start, but let's do a return. Return means it basically falls out, so it's only going to run this set destination here. And so now, yeah, I just want to make sure that our two objects find each other and yeah, and stop once they've found each other. Yep, now they're happy. Yeah, so this is, they're trying to find each other basically every frame inside of update. Does that make sense to everybody?
Yes, that makes sense. Now, a question for you. If you have an educational game and you want to increase the level of difficulty, how do you set that into the game?
Yeah, so some of it has to just do with testing, but over here in the inspector, this is where you can change the speed of your steering, the angular speed, the acceleration. You know, if you want the AI component to kind of go slowly, you could turn all of these properties down. If you wanted to make it kind of less intelligent as well, you could come into your profile here, into your humanoid agent profile, and you could have it so that, you know, they can't go up steep angles. You know, remember how we did it before where you just went over the walls? Yeah, you could have the AI agent forget, you know, after a certain amount of time, just kind of, you know, give up. It really depends on, you know, how you design it and what you want the functionality of your AI agent to be. Does that help, or do you have an example maybe that
Yes.
kind of?
So if there's a series, I'll make sure I'm on. If there are a series of questions that have to be answered before the player, you know, the human player can go to the next level, you know, just like there are levels in all the other games. But this is in, you know, not jumping to level 2. This is within the same level. They need to be able to answer some questions and make a decision. But based on their answers to the questions, the decision they make gets harder. So I'm just curious, is that something that works within this?
This is more for pathfinding. The system that you're talking about is more of a custom AI agent where you would be tracking information such as how many questions they've gotten wrong, how many questions they've attempted to answer, and a lot of that's customizable as well. We actually do that with our software. That's exactly what we do with our software. And so, yeah, it's really just a matter of tracking the statistics. Yeah, using your own custom algorithms, because sometimes you want it to get a little bit harder, or sometimes you want it to get a lot harder. If they really just are doing very well, then you don't want to force them to answer the same question over and over and over again. It's really time to send them to the next level. And a lot of that's just tweaking, looking at the numbers. If you've got an AI agent like that built into your software, usually you're recording all of that information into a database. And so, yeah, you can spit out that information and use Microsoft Excel to kind of look at the data. Yeah, it's really just a matter of, getting feedback from the people that are using the software and adjusting your algorithms and the properties and variables accordingly.
Okay, makes sense. Thank you very much.
Yep. Where are we at? Oh, I'm not sharing my screen. Sorry, I forgot I was. No, am I sharing my screen? I thought I was. Can you guys see my screen?
Yes, you are. We see it.
For some reason, I'm not able to see myself. I have two screens at once, just because if you recall, remember on that very first day, I was accidentally turned off my video and I was talking to myself for 5 minutes before Aaron contacted me and told me I wasn't in the class anymore. But yeah, for some reason on my secondary screen, I can't see myself. But as long as you guys can see my screen, I guess that's kind of what's important. Yeah, do you guys want to do more AI examples? We kind of, I got through all of the introductory nav mesh stuff I wanted to get through. Yeah, Adam, did you have any questions? You were able to get the stuff working where, both of the objects in our scene are able to come together. That all made sense. Because this is powerful code. This is how you get zombies to chase after you. This is how you get, if you're playing a strategy game, this is how you send your resources from one destination to another. It's a very powerful feature that's built into Unity. And we really just kind of, touched on the surface. You can optimize these so that if you're going across different terrain, there's ways of adding coefficients to different terrains, because sometimes, you can either go around a pond, or sometimes it's faster to go through the pond, even though swimming is slower than running, for example. And all of that magic kind of happens when you push the bake button. That's the button that creates all of the metadata on the back end. These different areas. This is kind of the difference between water or land. All right, if we don't have any questions, let's go ahead and start a new scene. I was going to have you guys do more UI stuff.
Hey, one thing before we move on.
Mm-hmm.
It's probably a simple fix, but having a problem where the player is moving towards the goal instead of like the opposite.
Okay, so back here, well, I put this player controller script on both. If we unchecked one, that now the player will go towards the goal and the goal will just sit there. Yeah, or if I wanted to do vice versa, I could uncheck the other player controller. And look how the player is actually pushing the ball around. That's because they both have colliders, and the way that the nav mesh agent is set up here is that he wants to get to a distance of 0.1, but because the colliders are larger, these game objects here are larger than 0.1, they have a radius of about 2. It never actually gets close enough, so he's just kind of always pushing that object around. If we wanted to get it so that goal didn't move, we could add a rigid body. Rigid body is the thing that adds physics here. We could add a rigid body, and then if you
But in order
is kinematic, then it will not move.
Yeah, so in order to have it work for the goal, it says it needs to have like a mesh agent put onto it. So.
Yeah, so if you've got a player controller, one of the things that the player controller references in the script is the nav mesh agent. And so you have to have a nav mesh agent on your player or goal or whatever it is that's using the AI as well. It kind of, the nav mesh agent allows that agent to use your nav mesh surface, and then that's how it knows where the obstacles are and how it knows where to steer, and the set destination function, that's really what sets where it's going, but all of the other things are determined automatically by the nav mesh agent component.
I see. Although now they're kind of moving at the same. And
yep. And if you don't want the one to move, then you can just take off the player controller and the nav mesh agent, and it'll sit there. Actually, either one. But if you only uncheck the nav mesh agent, then the player controller, I think, will cause null references because it doesn't know what to do. I actually even found, even if you have it unchecked, get component is still able to find the component, but then it's not able to actually do the set destination function because this component is turned off. Actually, rather than starting a new scene, we've got so many. We've already got a scene here. Let's just kind of add a UI to this scene as our next example. If we want to keep our current scene, say we like this scene and we don't want to mess it up or anything, we can save. We can come over to our project, and Control D is the magic duplicate. Sometimes it's Control C, Control V, but Control D in Unity is duplicate. So if we take our example scene and just push Control D, we get example 1, and so now we can call it example with GUI. And now we can go over to our example with GUI scene and alter this, and we'll still have our original example scene there. fresh if we want to go back to that again. So yeah, right now this scene behaves exactly like the other one did. I think we want nav mesh turned on. But let's go ahead and add a canvas now. If you right click on the hierarchy, you can go to UI, and let's go ahead and add some text again. See how it adds it kind of on this brand new camera again, where it's the size and everything is and position is kind of irrelevant because it's using a completely different position. If you click on game, you'll actually see what it looks like. So sometimes it's easier to see it in the game view because you have a better idea of what it looks like, and then you can take the handles here and adjust them so that yeah, we've got our text down there. If we wanted to display information in that text field about how close the two objects are from each other, let's go ahead and do that as an example. So go ahead and add text to your canvas, and then add a script file onto your text component and call it distance from goal. And then inside of the update function, go ahead and update that text field with the distance that the two objects are apart. And I'll give you a hint. There is a vector3.distance function that you can use. I'll be back in just a few minutes. All right. Let's see here. Are we able to get it? So basically, because our new distance from goal script is right on the text itself, as long as we're using the Unity dot engine dot UI, we should be able to just do get component text and set the text equal to, this is where our formula comes into place, vector3 dot distance, and these are the distance between the two objects. There's a couple of ways to do this. We could create properties, which is probably the best way of doing it. We do public game object player and public game object goal. And then in here, we want the distance between the player's transform position and the goal's transform position. And that's returning a vector3, which then wants to be turned into a string so that it can be displayed in the text, because text wants a string and a vector3 is not a string, and there's no automatic conversion from vector3 to string, so we just add one of our favorite functions of all programmers, toString. It turns it into a string. So now when we come back over to our inspector, all we have to do is drop those two game objects into our component, and now in real time we will get the distance between these two, yep, I had commented out the code having to do with where they were supposed to be going. Right now it's only in start again. I commented this out. If we want them to go together, which is a little more we don't want to totally lose the functionality of this. Let's go ahead and create use another Unity function called late update. Late update is just like update, except for it happens after update. And we can put this code there, so we still have our click functionality. And now, yeah, we can get rid of start, and we can get rid of this return. And now they will go towards each other. Although if you end up clicking on something, it'll get overwritten. Actually, this still won't work because every frame in update we have a destination. If we wanted to fix that, we would have to add, a Boolean, some kind of flag to let us know if we're actually at our position yet or not. Maybe we'll do that next, but let's go ahead and come back to our game and make sure that it's working the way we would expect it to work. And now, yep, they can't really get any closer than that because their colliders are just, yep, that's as close as they can get. If we wanted to change that so that they are happy with only being 1.03 apart and they aren't circling each other forever, we could come into here and our stopping distance, just change this to 1.5 instead. And now our player is happy, but the ball isn't, our goal isn't quite happy because it's still trying to get down to 0. if we set this equal to 1.5, now it's happy. Now they're content and not pushing each other around anymore. Although when we stop the game, our properties are going to go back to what they were before we started playing the game. So this goes back to 0, and player goes back to 0.1. But yeah, let's go ahead and, as an example, implement a flag so that whenever you click on something, both of our objects go to that destination. As an example. I don't get it. All right. Um, Oops, my logic was off. Yeah. Hope you guys were able to figure that out. Yeah, let me go through it real quick. We didn't really do anything too new. We used the same vector distance function that we used in our destination from goal function that we used in our canvas. But instead of getting the distance between our two predefined game objects, player and goal, we're actually getting the distance between, our current transformed position. So whatever, game object this particular player controller component is on, and our destination. And if that distance is less than 1.5, then we are at our destination. And at the same time, if we mouse down and we are not at our destination, then we're not at our destination, and it sets the destination to whatever we ended up clicking on the screen. I think my logic is actually flipped though. Yeah, we want to wait to make sure that we're actually at our position before we go racing off to another position. I think I just had that flipped. And we have to start off as true because we don't have a starting position. Let me think about this logically. If we're I think we just have to start off as true. Although I changed this to true, this didn't actually fix our problem. If you recall, this is just the default value that gets put into Unity whenever you drop this component onto a new game object. What we have to do in order to fix it is to come over to the inspector, come down to our player controller, and make sure that it starts off as at destination, because we're at our current destination, and it's our starting position. So now if we click somewhere, it will go there, and see, you can even see in the inspector we are now at our destination. So now if I click somewhere else, they're going to basically follow each other and go to that destination. Now they're less than 1.5 away from that particular destination. It looks like this player is a little bit faster. Now I clicked over here, and because our goal hadn't made it to the previous destination, that at destination flag wasn't true. So only the player ended up going to that new location. So similar, if we click here, our player got here already, but the other one didn't because he's slower. And so that's kind of how you can set up a AI racing algorithm here. Is this clear how we did this? I'll be sure to post all of the code and everything to our Slack channel, but I just want to make sure that I'm not going too fast, that everyone's able to kind of follow along with the stuff that I did, because there was a couple of formulas in there. I even kind of got my logic backwards the first time I did it. You know, I had a not symbol here, and it wasn't supposed to be, and this was supposed to be true as default. But yeah, this is just using you know, vector 3. Vector 3 is a very popular useful component slash function that you can use in Unity. Yeah, we've used it many times before. You almost have to if you're going to be making a 3D game. But at the same time, the inspector makes it a lot easier. You know, having the ability to switch back and forth between the scene and the game, so that you have multiple perspectives, makes it a lot easier. Yeah. Let's. Wanted to do a few more UI Canvas examples, just to make sure that you guys are understanding how this works. Let's go ahead and add a scroll bar, and that scroll bar will affect the height of our player. So when you adjust this bar here, it will actually adjust the height of our cylinder. Go ahead and give that a try. Oops. All right. So, give you guys a few more minutes. I'll test, make sure it works on my end too. Whoa. Our logic is off. So yeah, hopefully everyone's got their scroll bar on here. That's pretty easy. We wanted to add a script. You could call it whatever you wanted. I called mine adjust player height. And yeah, inside of our adjust player height, we have a reference to our player. And then all we're really doing is manipulating the scale of that player based on the scroll bar value. But does anyone see the error in my logic here? Does everyone have an idea why when we hit play here and adjust our scroll bar up a little, it grows and doesn't quit growing? And that's actually because in our logic here, it's accumulating, right? It's not actually tracking. It's getting larger by that amount every frame rather than scaling appropriately to the size of the scale. So what we want to do is we really want to keep track of its original height. And so inside of here, you can keep a private variable called original height. And because it's private, it won't show up in our inspector. All we really need to do is inside of start, make sure that this original height is getting set to whatever the player's original height was. So, and now rather than scaling and growing accumulatively, we end up just having the original height plus the value of our scroll bar. And now we come back over here and we hit play. We should be able to adjust it like so. Does this make sense to everybody? We can kind of see the reason that the distance between this object and this object is changing is because the center of our transform is actually changing. We could click on our player and scroll up here and look and see that our Y value is actually adjusting in addition to the scale. We got in the chat here for getting a bunch of syntax flags again. Yeah, Adam, do you want to go ahead and share your screen again, and we'll kind of step through and see what we can't find. I'm sure it's yeah, just a matter of looking at it and figuring out if it's a null reference or
yeah. So what I have, so yeah, now it's simply just
Is your teletext? It looks like your teletext is working now finally, which is good.
Well, it wasn't for. No, it wasn't for this actually.
Scroll over. It looks right. Maybe you might be missing a semicolon.
I have one there. It's just saying right parentheses.
Closing bracket. That's what you're missing. Well, you're also missing the Z value too, right? You've got the X there and you've got the Y there, and we need the Z value as well. Otherwise,
and so for that, I would do
height dot local scale. Yeah, your teletext isn't working 100%. It doesn't seem like.
Yeah.
But yeah, go ahead and hit save, and scroll back over again to the very beginning, or to the far left. I want to make sure you're not missing a colon. It looks right.
Though now it's saying that player height and if player height doesn't the script doesn't have a definition for local scale. Or is that the
yeah, it helps if teletext is working. It seems as though
okay, so I'll try.
Local scale you had right though. Let's see here. Yeah, my local scale, yeah, it's capital S, lowercase l, capital S. But yeah, this is the way you should be. For some reason, if I recall, your scroll bar wasn't turning the right color. Components are supposed to turn kind of this light teal blue color if it's recognized as a component. And this actually really depends on how you have your editor, your Visual Studio environment set up. Some people actually like dark background with light lettering. I feel this is I'm just, I guess, more familiar with this. I think it's actually easier on your eyes if you have a dark background, but really just a preference. Were you able to get it working? I would say, as a suggestion, close down Visual Studio and reopen it again. It's really just a whole lot easier if your teletext is working properly, because then, yeah, you end up only having to type about half of what you would normally have to type, and just the chance of you missing a letter or having the wrong capitalization somewhere, it goes down 90%.
Yeah, it's still saying it doesn't contain a definition for local scale.
Do you want to share your screen real quick again? I want to make sure. Yeah, you're able to get this working. Let's see here. We'll take a look at it one more time. It's complaining about local scale. So original height is a float. Local scale is a vector 3. So you want the Y value of the local scale.
So then.
Yep. So vector 3 consists of 3 floats, And yeah, we want our original height to be a float.
So yeah, so original height is a float.
Yep. But in your start function, you're trying to set original height equal to a vector 3. Local scale is a vector. So you have to add dot y at the end.
Dot y.
Yep. And dot y is a float. Although, what is your player height? Player height is actually the name of your class. You want to do player.local scale, right? Not player height in start method. Yeah, player height is player height is the name of your class. So I would go ahead and put in player. You want the local scale of your player. Capital P. Yep, and that should be all good. Now there was one more squiggly one. If you scroll over to the right, again, I think it just wants to be player instead of player height. Right there. Yep. And you are adjusting. Ooh, this could be interesting. Yeah. You hit save now. Is your console clear of errors?
Yeah, the console is clear.
So okay, go ahead and hit play and make sure that we're getting the functionality that we expected, where you can use the scroll bar to adjust the height of your player.
Yeah.
Does it work? Does it manipulate the transform size?
Let's see. Yeah, it does.
Okay. Good, good. Yeah, let me share my screen again. Yeah, we got about 5-10 minutes left. Should we go over another example where we're testing our ability to manipulate transforms, positions, and rotations and scales? Because that's really half of Unity, is just understanding the relationship between transform and game object and component. Everything else is, just kind of extra sprinkles on top. But the core functionality is being able to, manipulate things in your scene, and most of the manipulation just has to do with this most important component that everything in your hierarchy has, which is the transform. And then the UI handles things a little bit different, because you end up having a width and height, because everything's kind of relative. But if you wanted to, what happened to my? I'm zoomed in. That's why. I know my scroll bar is no longer on the screen. I think maybe something got manipulated here. My text is off too. Huh. Perhaps I moved something on my canvas somehow. I'm not sure how this stuff got off, but let's go ahead and move my text up a little bit where it belongs. I wasn't paying attention. Maybe our camera moved? I don't know. I have to go back and watch the video and see what happened. All of our UI components got off by a little bit here. Let's see here. Another test example. Let's go ahead and add a button in the upper right-hand corner that generates new players on our map somewhere. And they might even generate on top of one of our walls, but that's fine. They'll generate on top of the walls. But yeah, go ahead and create a prefab out of player and add a button so that whenever we hit the button, it generates a new player, and that player will have all of the same components where it has a nav mesh and everything. And whenever we click on a position on our map, all of the players will race to that position and compete for it, basically, because I think in order for them to shut off, they have to be a certain distance away, right? I think by default right now it's set to 0.1 still, so those players are going to push each other around. It might look kind of interesting. So go ahead and, yeah, try and create a button that generates random players on the map. Whoa, 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 whoa. This is a good refresher. Make sure you remember how to use the on-click functionality. I put my script on the ground just because I'm going to grab the size of the ground to determine where to put the new players and the position as well. Okay, Adam, if you got to go, that's fine. Yeah, class is wrapping up now. I'll finish this out and I'll post it to our Slack. Yeah, if you weren't able to get it done yet, but yeah, this will be a nice refresher of how to make buttons work and instantiate prefabs and set the transform of those newly instantiated prefabs. You know, I thought that our function would appear in here. Important to add keyword like void. Need to return a value and not have the function have the same name as the class. Otherwise, it assumes that it's a constructor. That's why I actually wasn't throwing any error messages because I forgot the void. It's because it was assuming that I was writing the constructor. And so because we had those issues, it wasn't showing up here as a potential function. You can't call constructors from here. It's looking for an actual function. And now that we've got it correct in here, we've got instantiate new player. And so now whenever we go to run and we hit generate player, it's generating new players, but it's generating them all basically on top of each other. They're all here. And so, yeah, if you were to disable them, you know, there'd still be one solo one sitting here. Oh, and the original. And so now we want to add some randomization so that they're not all sitting right on top of each other when they get instantiated. So we come back over here and we take these newly instantiated prefabs. Instantiate actually returns a game object, as you can see. So let's go ahead and keep a reference to our new player so that in our next line of code here, we can set the position of that new player to somewhere else on our map. Vector 3. Where are we going to put it here? We want to put it somewhere on our level. When you instantiate it, it instantiates it at the root of our scene. If you don't give it any variables, it assumes it's 0, 0, 0. That's the default vector 3 constructor. Let's go ahead and hit play. I'm a little curious as to where it's putting this position. So when we dropped our level on here, we weren't thinking ahead. Normally you want your level to be positioned at 0, 0, 0, but ours just kind of got put out in the middle of space. And so, here is 0, 0, 0. Over here it looks like interesting. Let's go ahead and move this guy a little bit this way. See how the colliders are still hitting each other. All of these players have the functionality the original one did. So if I click somewhere, our new players don't chase it down. It's because our at destination is false. We need to make sure that inside of our player controller, the at destination is true by default. Perhaps in the prefab, it's not right. Let's go ahead, go to our player. We'll select our prefab here. We'll open up our prefab. It is on by default. But for some reason, these ones aren't on. So the problem is actually in the way our raycasting works, because our code inside of player controller is setting this to false, and we never actually get to the destination because our destination is not on our canvas. We actually wanted to move this at destination so that we only want to perform that when you actually hit something. So this is supposed to be here. And now I think that should solve our problem. Let's go ahead and generate another player. And now everybody's racing towards that position. So yeah, can generate more players again. Yeah, if we wanted to randomly generate the position of the player, then we would need to plug a formula in here in our script. We can't just leave it as a blank vector 3, otherwise it'll always kind of put our new players over in the corner, which is okay for now. I think this actually is a pretty good stopping point. If you guys want to try and create that functionality so that it places the player randomly on the level, I think that's probably a good homework assignment, and we can cover it in class next week. Yeah, thanks again, and I'll see everybody on next Tuesday.